All right, so we've practiced finding all 6 ratios if we have a labeled triangle, but what if we don't have a labeled triangle? What if instead we have a ratio? First, you have to realize what sides you're being told. If you know in your brain that tangent is opposite over adjacent, then you can tell that 8 is your opposite and 6 is your adjacent. So you can come over here to a right triangle that you have drawn for you or you draw for yourself, and you fill out the opposite of the marked angle as 8 and the adjacent to the marked angle is 6. Okay? Find the length of the other missing side, says step 3. So a reminder that to find missing sides on right triangles, when you already know 2 of the sides, you can use the Pythagorean theorem. And remember that C must be the hypotenuse. Okay. No matter what, whether it's a variable or a number, C must be the hypotenuse. All right, our problem, hypotenuse is what we don't know, so we're going to put our x there for that. And we're going to set up Pythagorean theorem to find it. So a squared plus b squared equals c squared. It doesn't matter the order for a and b since they're just added. You can add in either order. So we get 8 squared plus 6 squared equals x squared. So we grab our calculator and we type in 8 squared plus 6 squared, we get 100 equals x squared. And to remove the square, we square root. Normally we would put plus or minus in front of a square root, but since this is on a shape, only positive 10 makes sense. So now we know that this side out here is 10, the hypotenuse is 10. So we can set up our other 5 ratios that they didn't already tell us. So we could have sine theta is opposite over hypotenuse, so 8 over 10. And cosine theta is adjacent over hypotenuse, so 6 over 10. And tangent's the one they told us. Tangent theta is 8 over 6. Okay, now remember the 6. The second 3 are reciprocals of the first 3 with new names. So sine is going to be 10 over 8. But what's most important is you remember that's cosecant, CSC for short. Cosine is going to be 10 over 6, but what's most important is that you remember that it's SEC for short, secant. And tangent will be 6 over 8, but what's most important is that that's called cotangent. Whoops, I forgot my line there. All right. On the next 2, we're just going to talk about the find the missing side part, and I'm going to assume that you'll be able to complete this box. Okay. So, some people are thrown off by this radical that's here. It's sine, so we have opposite over hypotenuse. So on our triangle, here's our right angle, so we're going to put square root of 50 here, hypotenuse. And opposite is 6, so we'll put that there. And x will be the adjacent. Okay, so before we can fill out the box with the 6 ratios, well, the other 5 besides sine, we have to find the missing value of the adjacent. So when we had to a squared plus b squared equals c squared this time, we can use 6 squared, but the adjacent will be x squared, and that'll equal square root of 50 squared. Which at first glance looks horrible, but when you think about it, it's not hard at all. Let's see, 6 squared, that's 36, plus x squared. square root squared. Square root squared. Square root and square are opposites. So all that's going to happen is they're going to cross out and you'll be left with 50. Really simple, actually. So then we subtract 36. X squared equals 14. And then remove the square or the square root. You're welcome to leave things that are not perfect squares in square root form when you put them back here on your triangle. I find it preferable to write square root of 14 instead of 3 point something something something. It's a decimal. But if you really want to make the decimal, then that's fine with me. Okay, let's set one more up just to be sure. All right, now this one's a little more thought-provoking because it doesn't give you one of the basic three. It gives you secant to start, or secant. So your first connection you need to make is that secant becomes cosine if you flip it back over. So my brain is going to flip this back over. Oh, right, I have a typo. That needed to be a 40. Okay, so when I flip it back over, that's going to be square root of 40. 4 over square root of 40. And I flip it back over because I've gotten cosine memorized a lot better than I have secant memorized. Cosine is the CAH, so this is adjacent and this is hypotenuse. So on my triangle, I have square root of 40 on my hypotenuse. And I don't know my opposite, so that's my x. And my adjacent is a 4. So when I set up my Pythagorean theorem to find x, I know my hypotenuse, I have to make that c. So I'll have x squared plus 4 squared equals square root of 40 squared. Hypotenuse must be alone. So we have x squared plus 16 equals square root squared, cancel off, so it equals 40. So we'll subtract 16, x squared equals 24. This will be another not perfect square when we square root. So you're welcome to leave it square root of 24, otherwise it'll be 4 point something something something. Again, you'll plug that in. And then you would do your 6 ratios after you have your entire triangle labeled. If you have questions, please ask in class.